2009 Toyota Camry. It's simply just got an alternator issue. It's making a loud whining noise, but I'm gonna just go through a quick diagnosing of this. Probably may take about 15 minutes, because I'm wondering, like, well, what if the alternator isn't bad? So we're just gonna go through a health check of the wire integrity and do some basic checks on this. This is the original alternator. I think it got like 120,000 miles or something like that on here. I have to look back at the clock and I'll tell you in a second. But it's got a crazy bad whining noise coming from it. I'm going to show you one thing you can do to isolate that issue and narrow it down to the alternator. A lot of times you can hear like a frequency type tone resonating from the alternator, and it's usually something internally going wrong with it as far as why it's doing that. I'm not that intelligent, and I won't really be able to give you a logical explanation as why, but it's a frequency noise. Sometimes it can sound like a bearing. It can sound like a bad bearing, but it's a frequency that you're hearing that's being that's resonating. Also, these clutches are good for going bad, but usually they have like a different type of noise, like a rattling, or sometimes they'll just freewheel. They're supposed to be able to turn one direction over another. I think that's kind of like not a smart design, so they're directionally biased. So let me start it up. You hear the noise, and I'm going to show you one thing you can do, and at the same time I'm just going to test the voltage. This battery was dead when it came in here. It is definitely a bad alternator, and I do have one on the way that I'm going to replace. So let's start it right quick. So that loud whine noise what I'm referring to, you can feel it. It's like vibrating real bad also. What you can do is just take the connector off, and the noise should shut up, which will indicate that is an alternator fault. So let me check the voltage level on this. I have my ground side on the battery. I'm going to take my positive lead here. Go right to the alternator. It should be making about 14 volts, but unfortunately it's pretty low, producing about 13. So the car was supposedly making 13 volts and is not doing that. So what we're going to do is just simply go through the wiring check. I had got some new piercing devices, and I was just playing around with them. That's why that sent the green and red wire is got some piercings in there. I was testing both of them. I had got them off of Amazon, the Amazon truck. Literally just pulled off, and I got these cheap ones off Amazon. I mean, they don't retain itself, but these piercing pins seem to be. I think this one's gonna work out a lot better than the cheaper one would. So, but we're gonna start checking some things. So I looked at the wiring diagram, and most of these are supposed to be producing 12 volts. And from looking at the wiring diagram, two of them look like it should be bias voltage or like a reference voltage. But that noise, it just seemed like it was just something some type of interference in there. I'm not that intelligent when it comes to alternators, but I do know they produce the AC voltage until excited, and you got some diodes inside of here that are directionally biased that will cause the voltage to go one direction out to the battery voltage wire here. So when you're testing the battery wire, it's a very simple test. You just make sure you got battery voltage from the battery, or you can do a resistance test from here to the other wire with the battery disconnected. The car is the key is on, engine's off. We're gonna go ahead and test this black and red wire, which should be our sensing wire here. So my black lead is on the ground side of the battery. Take my positive lead here. This should be constantly positive. Should produce a constant 12 volts here on the green and red wire. This would be the pin 1 if you're looking at the connector. So you got 1, 2, 3, and 4. Let's see what our sensing wire is producing, which is nothing. That's weird. Let me go to the other ones. So we got red, and then I know for a fact the yellow is going to be the L terminal, which is going to be the lamp. That should also be a bias voltage. It should be. That's 11, 3. So all these are 12 except for this one. Look at my notes. Now looking at the sensing wire, that should be in junction box under hood. So let's check that. It's a 7.5 fuse, so let's check that. Alright, so we're in the engine compartment on the left side here. I have my test light, and I'm just going to simply see here. Shoot, damn it. Golly. So it should be our AM2 fuse here. This is going to be our 7.5 AM2, and that is in fact blown. I'm curious now if I was to replace this, will the alternator start working fine, but I wonder if this simply just happened because of defective alternator. We do have fuses, some spare ones. I don't have a 7.5, but I still would feel better because of the mileage putting a new alternator on here. If this just should not blow for no reason, and this couldn't have been me playing with the piercing device because I didn't have anything grounded out. So I'm going to replace this, and we're going to continue checking on our wiring. So the fuse is now replaced. Let's see what we got now on our sensing wire. Okay, so yeah, that fixed that issue. And like I said, I don't feel comfortable. Activating the alternator, especially when that fuse is blue. And I got a replacement already in there, so I'm gonna leave that alone. I'm still just gonna put a new one in here. Again, because of the age, and if it blew once, it's gonna blow again. And from past experience, I remember I diagnosed the car, and the alternator was failing, and it didn't fail when I was testing it. And you know what? I gave the car back. This was years ago, and guess what? As soon as she got the car, it failed on her, and it left her stranded, and she had to get towed back. So yeah, I'm not taking chances. So we're gonna move on to. We're gonna check the red. Okay, here we go. We're gonna check the red wire now, which is gonna be the ignition. That should also be 12 volts. And let's see what we got. We do have 12 volts in the background. That should be, I'm going to take my test light here, ground that out. I should have actual voltage. And like I said, 2 shouldn't be supplying normal battery voltage. It should be like a bias voltage on 2 of these pins because they went through like resistors. So we're going to check sensing, the red and green for actual battery voltage. Yeah, so that's actual voltage. My light is illuminating, and battery voltage is illuminating also. So that's illuminating. That's illuminating. Now the red wire, which is the ignition wire, if your fuses is blown and you don't have any power, what you can do, since we're under the steering column here, reach under here, there's going to be your fuse there, and I pulled it out a couple times, so that's why it kind of looks like that for me grabbing with the pliers. But that's going to be that red wire we just tested, which is going to be the ignition fuse, and it's located in the car. It's the AM1 fuse. All right, so we checked our S terminal, which is the sensing, and the fusible link is located in the engine compartment. We've checked the red wire here. It's going to be a 2 terminal, which is the IG ignition. That fusible link is located inside the vehicle. It's at 7.5. They both have 7.5 amp fuses. Gosh, I'm screwing up life. So we're going to check the yellow, which is going to be the L terminal, which is going to be the lamp. That is supposed to have bias voltage, or like a reference. Now inside of here we have a MIC unit. It's called a monolithic integrated circuit, and what that do is it basically comprises of various. It's a single unit that comprises of, I want to say, just transistors. So you have those transistors that direct current to certain places, and I saw when I looked at the wiring diagram, it was 3 of them. Looked like 3, it's probably like 3 or more, but from the diagram it looked like it was 3 in there. And basically this bias voltage has a resistor in the circuit, and it's enough to transition that base to open, and I think that's considered a gate when it comes to transistors, because they're 3-pin, and that center pin, if I think it's called the base or the gate or something like that. And I think that's what will allow the collector and the emitter to either activate or deactivate on those circuits there. So I'm not too familiar with transistors, because I mean there's like so many types, like PNP or NPN, and you know, like, I guess something like bipolar and all, so that I can't remember all that stuff, man. I ain't that bright. But what they do is they can take voltage, very small amounts of voltage, and rapidly switch. Some are faster than others, but that's not what we're talking about. But basically those MIC unit basically consists of those, which allow those transistors to do their job, and that's what these are connected to. Is going to that device inside there, and it's distributing power. So we have now these two, again, these were actual power sources, and that supplied legitimate voltage because those fusible links were attainable. We saw them. We are going to check, once I find my lead for my positive, we're going to check that positive. I can get this camera over here. So we're going to check our bulb. Now if your bulb is defective, it's not going to send a signal to the alternator to excite it. So it has to see this bias voltage here. So we're going to go to our yellow wire, and we do have a voltage value of 7.4, and I wonder if that's because the battery is probably going a little low. Let me check these other ones. Yeah, it's about 730, 7.30. I'm going to put the battery charger just real quick. Alright, let's see how our voltage is looking now with the battery charger. Yellow terminal. Yeah, we got 13 volts now on that yellow wire. Now, again, to check that yellow wire, hook this connector up to the alternator, and just turn the key on and off. If you see the battery light on the dash illuminate, then you have a functioning light. You don't have to worry about it. And again, it should be bias voltage. So those two that we check the fusible links on will illuminate, which they are. Now the bottom two shouldn't. So the yellow wire here goes to our bulb, which was a bias voltage, and that's not illuminating. And the other one goes to our computer, that's not illuminating, but the two top there. So now we're going to check the final wire, which is the one that goes to our computer. That lower wire here, the blue wire, is what they call the M terminal, or it's going to be the field wire. Alright, we're hooked up on the M terminal, and that's going to the computer system. That's the blue wire here. And if I'm on DC right now, and it is oscillating between 0 volts and 5 volts. I'm not sure exactly why, but my thought process behind this is maybe because of the powers going to the MIC, the monolithic integrated circuit, that since those transistors aren't energized, they're just getting current. And I think that current there, because of those diodes being in the place that they're in, maybe that's what's causing to like oscillate in that fashion. And if I put it on AC, it'll definitely like oscillate. I'm not sure if it's supposed to be on that, but I do remember reading a source where you can check the diodes on one of these pins, and there was some more technical information there, and I'm like, I got a GD here, you know, we're not engineer status, but I'm going to use this as some comparative info. And like I said, I'm just thinking that because of how transistors operate in the series, in the fashion in which they are wired in, the diodes being directionally biased, and being that they're not, being that the alternator itself isn't producing any voltage, that's probably why we got what we got. It's just my thought here. So what I'm going to do, I'm going to get a snapshot of this, and I'm going to get a snapshot of it operating. So when I start the car up, we'll see what happens, and I'm going to get a snapshot of that, because I really need to get this alternator on here and get this job out of the way. Alright, the alternator is installed. We're going to go ahead and take a look at our data again. And this is just me confirming whatever I think about this this signaling, well, the M terminal, or I think it should be considered an F terminal. I'm not sure why, but it's considered an M terminal in Identifix. So I don't know, depending if you Google it, it'll come up with something else. So what's going on? So with the key on, engine off, we have different values now. Before it was at 6 volts or something like half of this. Now it's at 12 volts with the brand new alternator, key on, engine off. So what I'm going to do, I'm going to start it up, and we're going to take a look at it. This would just drop, and it would have no reading. So I mean, it should be a consistent wave, as we're seeing now, as it would when it would start up. So I guess it's like a confirmation type signaling, but strangely it didn't trigger any codes in the check engine or check engine light or anything, and I didn't have any generator type settings I could venture off into the test. So as far as far as replacement, it's a very simple replacement, nothing major. Hopefully we'll learn a little bit about how to diagnose and check this. Now, I will go back and say the reason why that fuse was blown was on my part, and I'll explain why. I did a video a while ago about these terminals for the Maxi scope grounding out, and I remember a guy asking about, well, can you damage a computer? It was a question he asked a long time ago, and we had a couple exchanges in regards to that. But this is that case where you can damage a component. I mean, that the positive lead, the insulation, the noise reducing sleeve grounded out to the point where it caused me to blow the fuse when I was piercing that that sensing wire, and that's why I had no voltage or anything, because it blew that fuse under the hood, which is the one we checked. So to answer the question, this is that case where it could damage components. I mean, if that computer had some type of, well, they normally don't, but if the computer had like voltage coming from it, and I would have potentially damaged the computer. Computers normally have like a reference voltage, but if it was a 5-volt reference, it could still short out the 5-volt reference. Might not blow, might not damage it internally, but it could, and that's that case there I'm referring to. But I digress. So that was me, my doing, but we still learned something new. So we checked all the wires, and this is a healthy system here. The alternator is working appropriately, and if you ever have any issues with your vehicle, your 2009 Toyota Camry, it's a 2-way ZFE model. This is one of the motors, the same motor, not this exact motor, but I rebuilt this type of engine. My power shutting off of my Maxi, my Altail. But other than that, we'll see how this hold up. This is a brand new alternator from O'Reilly's, my part store I frequently patronize, to get patronized. And we'll see what happens. Other than that, hit that link, subscribe to the channel, stay informed, have that reassurance in my work. See you on the next one.